In this video, we're going to have a look at sign diagrams to find out where functions are increasing, decreasing, or turning. So we know that if the slope is going up, we would say that it is increasing. So if we look at it from left to right, it's always going up. Conversely, going down if it's decreasing across as we go. So sign diagrams are a way that we can demonstrate whether a function is increasing or decreasing. And the crucial point is where the derivative is equal to 0. So you derive the function and then set it equal to 0. Let's have a look at what that means. So in this example here, we can see that it's got a turning point here. Now we know that the slope here is going to be 0, but we don't know where that is. We know that by looking at it, it's going to be 0. It's decreasing, it's turning to 0, and then it's increasing after that. For negative x squared, it's increasing, and then it's decreasing. So there it is. How do you know whether it's a plus or a minus? Well, you choose a number less than 0. So I'm going to choose a number less, which is negative 1. So if I have I've derived the function. Now I'm going to put in negative 1. Negative 2 times negative 1 is equal to positive 2. Now, it's a positive number, so that means that it's going to be a positive in here. If I choose a number greater than 0, I can put that into my equation. So if I said the f of 1, negative 2 times 1 gives me negative 2. So it's a negative, which means that it's going to be decreasing. We also have other functions that increase, flatten out, and then continue to increase. So these are called points of inflection. So if we have a local maximum, that's where it's going up, it's turning and going down. So it has that shape. A minimum is the opposite, where it drops down as low, but it's a local minimum. And a point of inflection is where it turns and continues. So if this one is going down and down, showing a negative slope here, and then it hits point A where it flattens out to the slope being 0 and then continues to go down. So let's have a look at a couple of examples here. Find the intervals where f of x is increasing or decreasing. So firstly, I'm going to find f dash x, so it's going to be 6x squared plus 6x take 12. Now, I've got to find the points where this is equal to 0, because we know that these points are when f dash x is equal to 0. So 6x squared plus 6x take 12 is equal to 0. Now, I don't know how to do that just by looking at it, so I'm going to come over to my calculator and go into the equation setting. I'm going to do a polynomial with degree of 2, and my a value is 6, 6, and negative 12. Okay, so now it tells me that my points are negative 1 and negative 2. So on my sign diagram, I've got negative 2 and 1. So I'm going to insert some numbers here. So a number between negative 2 and 1, I'm going to pick 0. Always the easiest option. I'm going to insert it into the equation. So 6 times 0 plus 6 times 0 is still 0. Take 12. It's a negative number. So that means it's going to be decreasing in this section here. I'm going to choose a number which is less than negative 2. So I might choose negative 3. So 6 times negative 3 squared plus 6 times negative 3 take 12. So that's going to be 9. 54 take 18 take 12. And I know that's going to be a positive number. And then I might choose a number greater than 1. Choose a round number, maybe 10. So 100, 600 plus 60 take 12. I know that's going to be positive as well. So if I had to look at this, I'd say that it would be increasing, and then it's hitting the point at negative 2, and then it's decreasing, and then it's hitting the point at 1 where it begins to increase again. So that is how you use sign diagrams to sketch out a function.